All right, good afternoon and welcome to the first of our fall 2023 webinars, the UCGS series. I'm Amy Brock, I'm the Executive Director of UCGIS. And if you haven't already been aware, on our webinars page, we have a list of webinars. We'll have the forthcoming ones as we get them, we post them. And if you're a UCGIS member, you can just log in and then you'll be able to access recordings of past webinars. Today we have Dr. Ling Bian, who's going to be our moderator, and our presenter will be Dr. Stuart Fotheringham. If you have general comments you want to make, you can use the chat, but any questions that you have for the speaker or the moderator, please put those in the Q&A. And I'm going to turn it over to Dr. Bian.
Thank you, Amy. Can you hear me clear? Okay, good. I like first acknowledge UCGIS effort to make this webinar happen. The efforts include the leaders of the Research Committee, Education Committee, Communication Committee, board members, and the 3 presidents, and of course, the Executive Director of UCGIS, Amy, who just introduced the webinar. Now, Professor Fotheringham does not need an introduction, so I skip his long resume. He's a professor in the School of Geographical Sciences and Urban Planning at the Arizona State University, also a member of the U.S. National Academy of Sciences. And his work on what we now call GWR, geographically weighted regression, and a series of derivatives. And these methods, this approach is widely used and well-known. So today, Dr. Fotheringham's presentation will be based on a philosophical conceptual discussion recently published in the Annals of AAG. And I read the paper and I thought it's very important for Dr. Fotheringham to share his thoughts with the UCGIS community. So without further ado, here's Professor Fotheringham.
Thank you very much, Professor Bian, and thank you very much to the UCGIS for inviting me to participate in your seminar series. Let me just start sharing my screen. Okay, hopefully everybody can see this now, and I'm sure Professor Bian will let me know if there's a problem anywhere. So the presentation I'm going to talk to you today about is called Measuring the Unmeasurable. It's a slightly enigmatic title, Models of Geographical Context. It comes from a paper in press in the Annals, and it's currently available online, and it's freely available through open access, and there's a link to it. So you can download the paper, and it's got all the references that I'll be making in this presentation. Yeah. So the structure of the presentation is as follows. First of all, I'm going to look at, does place matter? Then I'm going to focus on context. And I'm going to look at some models that incorporate context. And I'm going to test these models using some voting data from the most recent 2020 US presidential election. And then there's a summary. So I think there are 53 slides in total, and it should take me roughly about 45 minutes. Okay. So basically, does place matter? That's the big question. And it's a big question in geography, because often geography is defined as place matters. If it didn't matter, there wouldn't be much of a geography program. And it certainly does in physical and environmental geography. The Earth is obviously, unless you're a flat Earth Society member, the Earth is a tilted sphere. So sunlight intensity and duration, and hence large elements of climate, vary by place. Flora and fauna have evolved. Again, unless you're a creationist, flora and fauna have evolved differently because of climate variations, and hence they vary by place. But the big question is, does place matter in human geography? And specifically, does place affect human decision-making and behavior? by somehow influencing the things that influence our behavior, the beliefs, values, norms, etc., things we can't generally measure. And these are independent from who we are. So I'm not talking about place affecting decision-making by having different types of people in those places. I'm taking the situation where, suppose everybody were the same everywhere. Does place still matter? Does where you live, does where you come from affect your behavior? That's what we're trying to understand. So this debate about the role of place has contributed to a schism in the social sciences, broadly between those who believe there is little point in searching for regularities and trying to model human behavior, because place plays a big role in it. And that's a sort of non-scientific viewpoint. And on the opposite side of the coin are those who believe that the search for regularities through modeling provides some valuable insights into human behavior. And that's the sort of scientific viewpoint. Now, in this paper, and I should mention my co-author on this paper, by the way, is Professor Ziqi Li from Florida State University. In this paper, we're proposing a third way, a middle way, and that is where place is or can be important in affecting human behavior. We recognize that, but we can incorporate the effect of place into our models, and that will improve both our models and our understanding of human behavior. So this is a scientific viewpoint, but it's one that recognizes the potential importance of place. And I'm going to demonstrate this using 3 different modeling approaches, which fortunately generate similar results on quantifying the role of place on behavior. And these 3 techniques are multi-scale geographic weighted regression, MGWR, spatial error models, SEM, and multi-level models, MLM. So the third way that I'm proposing, or we're proposing in this paper, rebuts criticisms about positivist types of geography and quantitative research, which have been around for a long time, since the Hartshorne-Schaefer debate in the 1950s. Summarized by a couple of quotations here. This is one is from Johnson and Sidaway, the 7th edition of their famous book, The Geography and Geographers. They're not making a criticism themselves, they're just relaying the criticism from other people. For others, however, the human condition can only be discerned through humanistic endeavor, or attitudes, impressions, and subjective relations to places, that's the sense of place, cannot be revealed by positivist research. I'm going to rebut that criticism. And another one by Kitchen in a chapter on positivist geography in the Aitken and Valentine book in 2006. In effect, it was argued that spatial science was peopleless, in the sense that it did not acknowledge people's beliefs, values, opinions, feelings, and so on, and their role in shaping everyday geographies. So we'll see how quantitative geography can actually incorporate all these issues that the people have been criticizing it for not having. So second element now, focus on context. The raison d'etre of place-based geographies is that location affects decision-making. And that would lead to spatially varying behavior. And somehow this is independent of the identifiable factors that describe both a location and its inhabitants. And we call this geographical context, or I'm going to just call it context for short. It's been suggested as important by many researchers. I'm not going to list them all, it would be far too many, but here are some of the big names that have talked about the importance of context. Now, let me give you an example of what I mean by context. And this is from voting in the 2020 election, the presidential election. So here are there are 2 counties. I'm not going to label them yet, but the first column we'll call County A, the second column we'll call County B. They are very similar, in fact, in terms of the attributes which are listed on the left-hand column that affect the things that affect voting behavior, generally perceived to affect voting behavior. I've chosen these 2 counties because they are very similar in terms of their socioeconomic profiles. They've got a very similar population. Get my mouse up. They're a very similar population, very similar gender ratio, very similar age profile, very similar, almost identical population density. They differ on a few things. Obviously, you can't get 2 counties which are identical. County B has a high proportion of Black population. It also has a high proportion of Hispanics. It has a slightly lower proportion of people who are educated to degree level, lower incomes, It's got slightly a lower proportion of people employed in manufacturing, and the turnout in the election was a bit low. And the bottom one here is a much higher proportion of people with no health insurance, which was deemed to be important, particularly in the last election. It was deciding on whether you're going to vote for the Republican Party or the Democratic Party. So the question is, seeing these kind of profiles, how did these two counties vote in terms of the vote for the percentage of people voting for the Democratic Party? Now, given that they're very similar in terms of their profiles, with a few slight differences, you might expect that they were quite similar in terms of their voting patterns. Well, I'll tell you that County A, 57% of County A voted for the Democratic Party in the 2020 elections. Now, County B, if I force you to decide, is that going to be higher or lower, which way would you go, or is it about the same? Well, you might be forgiven for thinking, well, it's probably going to be about the same, or it might be a bit higher because some of the attributes on which it scores highly are associated with voting for the Democratic Party. Black voters, Hispanic voters tend to ally themselves with the Democratic Party. People without health insurance would typically, you'd think, would ally themselves with the Democratic Party. But in fact, if you look at the way this county voted, only 18% of that county voted for the Democratic Party. Now, why is that? There are no variables to suggest why this would be the case. And basically, it's something to do with location. So if I tell you that this county is in Wisconsin, it's in southern Wisconsin, it's called Iowa County, and this county is in eastern Texas, it abuts the Louisiana border, it's Panola County in Texas, then immediately you think, oh yeah, okay, so people in Texas tend to vote Republican, people in southern Wisconsin tend to vote Democrat. So you sort of explain it to yourself, but that's through context, right? It's through the location of these places. There's nothing in terms of their socio-economic makeup, socio-demographic profiles that would suggest this huge difference in voting behavior. So how might these contextual effects arise? Well, there are various possibilities here. It's now fairly well recognized, and there's a big rise in this thing called geopsychology, that personality variations occur across places. There's a whole book on this kind of thing in different nations, American nations. And there's a lot of research, both in geography and in psychology literature, demonstrating these kind of personality, psychological profile differences of people across countries. There's also the influence of local media and selective news representation. Very few people these days read a neutral media or listen to a neutral media. And the slanted view that they get from their local media can have a strong influence on both what they believe and how they behave. And there's quite a lot of work done on that. Bishop, in his book, The Big Sort, in 2009, claims that we live in gated media communities. We just listen to the arguments that support our views, which is confirmation bias, and we don't really listen to anything else. The classic thing is people listen to CNN News or Fox News and rarely do they switch between the two. Then you've got the influence of family, friends, and local organizations. Basically, this is often referred to as social imitation. It's who you talk to on a daily basis can affect how you feel about things. And there's a human desire to fit in with people around us. And there's a lot of work in political science and sociology on this phenomenon. So whatever factors there are responsible for people's values and their actions being influenced by where they live, it's amplified by two things. One is group polarization. So over time, groups generally become more extreme in the direction of the average opinion of individual group members. There are various reasons for doing that. Approbation from the group, wanting to fit in, etc. And also selective migration. There's a very strong tendency of people to, when they move, to seek out like-minded individuals. That's homophily, or either that or avoid people with dissimilar views. That's xenophobia. And again, there's lots of work being done on that. And you can see the result of that by the paradox in US elections, presidential elections, where the overall vote share, certainly in recent elections, has been very close, 50-50 almost. But locally, that rarely happens. Locally, lots of people live in districts where there are landslides. And so we have this kind of shifting of people to join like-minded people. So there are various reasons for thinking that context can play a role in our lives. But the counter argument to this, which has been made by several people, is that, well, yeah, isn't context just a catch-all term for things we should be including in our model? And if we're good scientists, then we should be eliminating context by including all these things in our model, which is a fair argument. But there are two counter arguments to it, I think. One is that in theory, yes, I agree with this sentiment, but in practice, as we all know, it's generally impossible. How do you quantify people's beliefs and aspirations and feelings, etc.? The argument we're making here is that it's better to capture a general contextual effect within a model rather than ignoring it, which is what we typically do. If you ignore the contextual effect, and if it's real, then you're likely, you leave yourself prone to misspecification bias, sometimes severe misspecification bias, in the remaining parameter estimates in your model caused by an omitted variable. And a couple of my earliest papers back in the early 80s, 83, 84, were on this topic in terms of distance decay parameters within spatial interaction models. So I'm returning to this theme. The second argument, a counter argument to this idea that, yeah, we should just ignore context or try and remove it, is that spatial context can influence our behavior in two ways. And much of the debate regarding the role of context has arisen because there's either been confusion over these two roles or ignorance of one of them. And let me explain this. So here we have behavior at the top, and it doesn't matter what type of human behavior we're talking about. That's a very, very, very broad topic, okay? And we all have our own little niches within this. When we come to model behavior, whatever the topic, we form a model, and in that model, we have a series of measured exogenous effects. These are our covariates. There are always going to be some unmeasured effects that we can't include within our model. Now, of these unmeasured effects, and this is going to sound a bit like Donald Rumsfeld here, of these unmeasured effects, there are measurable unmeasured effects and unmeasurable measured effects. These, the measurable effects, unmeasured effects, are things which King and others, etc., quite rightly say we should be removing. We should be trying our best to remove all of these measurable effects. We haven't measured because I don't know why, we haven't got data on them or something. We've just not thought about these variables. So we should be getting rid of those. But there are always going to be something which is unmeasurable, again, relating to feelings, aspirations, etc. of people. And these form what we call in this paper, intrinsic contextual effects. So that's one type of contextual effect, these things which we can't possibly incorporate within our model. But there's another type of contextual effect which relates to these effects over here, the things we have included in our model. Now, these can have a global impact. That is, if you change one of them, it'll have the same impact on behavior everywhere in space, or their impact might be spatially varying. If you change one of these variables in one part of your study area, it might have a different effect to changing it in a different part of the study area. These spatially varying impacts lead us to another type of contextual effect, which we call behavioral contextual effects. This is when the parameter estimates of our models vary over space. We have spatial non-stationarity in the processes that we're modeling. So a couple of examples there down here of what I mean by these two things. So intrinsic contextual effects would occur if, for example, there was a greater preference for the Democratic Party in, say, Western Oregon than there is in Alabama, everything else being equal. If you had the same people in Alabama and in Western Oregon, and then looked at their predilection for voting Democrat, is it the same? And the argument here would be, no, it probably isn't the same. There's something about location, living in Western Oregon, that makes you lean towards voting for the Democratic Party more than if you were living in Alabama. In an example of behavioral contextual effects is, for example, if older voters had a preference for the Democrats in, say, Florida, but a preference for the Republican Party in Texas, everything else being equal. So again, this is different behavior over space. In one part of the country, older voters tend to have a preference for one party. In another part of the country, they have a preference for a different party. That's a behavioral contextual effect. There's something about space which is changing the way people respond to a particular stimulus, for example. So despite, I think, a general acceptance that context can affect people's behavior, I think most people would accept that, and meaning place matters. There are various questions about its role. First, the major one is how important is it? If it's just a minor part of explaining our behavior, then yeah, we can probably it's okay to ignore it. But it might be very important. As Enos, in his book, The Space Between Us, which is all about context, 2017, says, nobody doubts that context can affect behavior. However, the exact nature of contextual effects, how much they really matter, is elusive to researchers. And that's echoed by O'Loughlin in his editorial piece of 30 years of being editor of political geography. But if context has remained a mantra in political geography, how do we measure its importance? A second question is, how can we separate the effects of context from other variables? So we've got all these other things in our model, and then basically we're adding context. How do we separate the effects of context from these other variables? One of my colleagues, DSU, Dylan Connor, wrote an article with Michael Stauper in 2020 in the PNAS, in which they called the separation of contextual effects from other influences on behavior a classic challenge in social sciences. I'm going to rise to that challenge and show you how we can do this. The third question is, at what scale do contextual effects operate? Spatial scale, I did. Is it at the neighborhood level, the city level, street level, county level? What is it at? State level? And do all contextual effects operate at the same spatial scale? Perhaps some operate at a very local scale, others might operate at a regional scale, and others might be national. Sayre anticipated this in 2020 in a book on covering basically philosophy and human geography. Such problems raise the fundamental questions of how far and at what depth a social structures and processes context dependent. Okay, so there are several modeling frameworks that exist that actually incorporate context. One is, as I mentioned, multi-scale geographic weighted regression. Another is spatial error modeling, and a third is multi-level modeling. So I'm going to look at how these do this. So how do we incorporate contextual effects within multi-scale geographic weighted regression? Well, here's a formula for standard multi-scale geographic weighted regression. We've got a variable that we're interested in, its distribution y here, and I is a location in space. We have a series of covariates, x1, x2, up to xk, and we have parameter estimates in this model, which are specific to each location, I. So the intercept is locally varying, and the slope parameters here, beta 1, beta 2, etc., are all locally varying. The models, we can calibrate this even when we've got cross-sectional data. Typically, we only have one observation at each location by borrowing data around each location. And these when we estimate the parameters of this model, the local intercept terms give us our intrinsic contextual effects, and the local slope parameters give us our behavioral contextual effects. Now, I'm not going to go into the detail of how this is all done. It's beyond this talk, but there is a book coming out next month, published by Routledge, Multi-Scale Geographic Weighted Regression, Theory and Practice, just in time for the Christmas market. It's a steal at about $100. It's co-authored by myself and Taylor Oshan and Zichi Lee. All right. So we can use MGWR not only to identify both intrinsic and behavioral contextual effects, but also to quantify the separate effects of place versus people. We can actually use this to say how important context is versus how important the socio-demographic profiles of places are in affecting people's behavior. And to see this, consider the local model written in terms of standardized variables. Standardized variables have a mean of 0 and a variance standard deviation of 1. So here's the local model, MGWR, written in terms of standardized variables, which is what we normally do in order to get bandwidths, which tells the scale at which different processes operate, which are comparable. So yi starred here and xi k starred represent standardized forms of our variables. If you rewrite this in terms of the original unstandardized variables, so that's a standardized version of y. It's simply subtracting the mean from y and divided by its standard error, and the same thing for the x variables. If you take that formula and then rearrange it, so basically just multiply through by the standard deviation of y and take the mean of y on the other side of the equation, you get this expression down here. This has got 4 components to it. It's basically saying y, the thing we're interested in, is made up of 4 components. One is a mean level, an average value. And then we have a contribution which is due to place, which is to do with the local intercept terms. Then we've got a contribution due to the population composition of each location, which is that term, and then a random component. And we're going to use that to show what the contribution due to place is compared to the contribution due to population composition. There are 2 other frameworks that contain that allow us to model context. Second one is spatial error models. So here's the spatial error model formulation. Y is regressed on a whole series of x's. Here it's matrix notation here, and we have an error component which is spatially dependent. Has a spatially dependent term to it. Lambda is a spatial or regressive parameter. W is a spatial weight matrix. And so we have a dependency in our error terms here. And if we put those 2 together, we combine these equations, we get this one down here, which looks like a bit like GWR, because that's a locally varying intercept term. So this modeling framework can measure intrinsic contextual effects similar to a local model. It can't measure behavioral contextual effects because these parameters are fixed. They don't vary over space, but it does have a local intercept. Multi-level models also contain have the ability to measure contextual effects. For a multi-level model, you have to specify a spatial hierarchy. And let's just take a simple two-stage hierarchy. We've got locations I embedded in regions P. So we've got our interest here, y, location I in region P, and that's a function of basically a series of covariates measured for each location I in region P. And we've got parameter estimates which are specific to each region P. So the intercept and slope parameters can vary between regions. They've got a fixed term and a region-specific term attached to them. So this one, the intercept term, tells us something about intrinsic contextual effects, and the other 2, the slope parameters, tell us something about behavioral contextual effects. So again, it's doing something similar to multi-scale geographic weighted regression. Okay, let's have a look at how these models work in the real life. And I'm going to take as my test bed voting in the 2020 US presidential election. So this basically was a de facto survey of about 160 million people across the US who revealed their preferences. It wasn't a hypothetical, it was an actual preference they made, and they made it for either a Republican or a Democrat to be president. Third-party votes were very small, around 3% of the votes were cast for third-party candidates. Now, the data have been aggregated into the percentage of Republican and percentage of Democrat voters in a straight fight for each. So it's just between those 2. For each of the counties across the US, just over 3,000. But because some of these counties have very small populations, we excluded those from the analysis because a lot of our data, a lot of our variables are percentages, and they're going to be very sensitive to small numbers. So we removed counties which had a small population base, under 5,000, and that left 2,807 counties for our analysis. And along with the voting data, we have data for each county on 14 covariates which are thought to influence voting preferences. So these are the data that we're interested in, the pattern that we're interested in. This is how we voted in the last election, Biden versus Trump, part 1. And the red areas are where these are the actual votes by county, percentages, voting for the Democratic Party. So anywhere in red here, the majority of people voted for the Republican Party. Anywhere that's blue, the majority voted for the Democratic Party. the Democratic, the blue areas are mainly most of the urban areas with large populations. Oops, sorry. So we're interested in this voting pattern. What's causing this extreme? In some places, 97% of the population voted Republican. And some other counties, 94% of the population voted for the Democratic Party. Huge variations across the country. What's caused that? Well, we've got from the literature and from news media and just using common sense, we picked 14 socioeconomic variables which appear to be influential in determining voting behavior. There are demographic variables, age, we've got young voters, old voters, gender, ethnicity, Hispanic and Black populations, foreign-born, education, university education, population density, which is an urban-rural divider. And then we have some economic variables, income disparities, the range of incomes within a county, proportion of people with health insurance, because that was a big issue in the last election, and then proportion of people employed in the manufacturing sector. And then we've got a couple of voting behaviors, turnout. We're interested in finding out whether an increased turnout was beneficial to the Democratic Party or the Republican Party. And then also third-party voting, the proportion of people who voted for a third-party candidate, did that detract more from the Democrats or more from the Republicans? So we've got a model which we can then calibrate with our various context models. So the basic question we're asking is, when people voted Democrat or Republican, to what extent was that vote, that decision, made in terms of their makeup, their socio-demographic and economic kind of factors, or to what extent was it influenced by location? So does where you live influence how you vote? And if so, was that quite a strong impact? And it's not just a direct impact like that. Location also has an impact on how these socio-demographic factors might influence how people voted. But these are the behavioral contextual effects. This is the direct intrinsic contextual effect that we're interested in. How strong are these effects? If they're only kind of weak, then we can just ignore them. But if they're pretty strong, then we should be including them in our models. So using these data, we calibrated the three models I previously described, a couple of operational issues. For MGWR, we used an adaptive kernel with a bi-squared weighting function. For the multi-level modeling, we allowed the random effects to operate at the state level. You have to pick a hierarchy here. We picked states, so counties are embedded in states. And for the spatial error models, we fitted models with, you've got to pick a spatial weight matrix. Now that can have it's subjective to some extent, and it can have a major influence on the outcome. So we picked two types of spatial weight matrix, the contiguity-based weighting matrix and an optimal k-nearest neighbors weighting matrix. The optimal value was 14 in this case. So we actually ran two different types of spatial error models with different spatial weight matrices. For a general comparison of goodness of fit, the R-squared values for MGWR and MLM were pretty high, 0.95 and 0.93. For the spatial error models are a bit lower because they don't model the behavioral contextual effects. Right? They only model the intrinsic contextual effects. So what did it look like? Well, here are maps of the intrinsic contextual effects from the four models. That's MGWR. This is multi-level modeling, and these are the two spatial error models. And you can see that the patterns are very similar in all four cases. Obviously, the pattern for multi-level modeling is rather crude because we're limited to displaying it by state. And the assumption is that the process is the same across the state. We're not allowing it, that can't vary. It only varies across the states. So that's a bit of a cruder representation. But you see the same kind of pattern appearing, that anywhere that's red on this map, the local intercept is negative, which means there's an intrinsic preference for the Republican Party. Anywhere that's blue means it's the parameter is positive. It means there's an intrinsic preference for the Democratic Party. And that's saying that holding everything else constant in our model, if everywhere, every county had exactly the same population profile, they would not vote identically. This is how they would vote. That's what this is saying. All these counties in the South would vote, majority of people would vote for the Republican Party. Anywhere that's blue up here, the majority of people would vote for the Democratic Party, even if they were all identical. That's the thing we're measuring here. But there's something intrinsic. There's something about living in the South, which we haven't incorporated in our models, but it just leads you to be more likely to vote for the Republican Party than the Democratic Party. And there's something about living in New England, the upper Midwest, and the West Coast that leads you, no matter who you are, to be more likely to vote for the Democratic Party. And that's repeated, that same pattern you can see in all four models, which is reassuring. We also have the ability to measure behavioral contextual effects, how these variables that we've got, the 14 variables, affect other spatial variations in the way that these variables can affect the probability that we vote for the Democratic Party. And again, we can compare two models. We can't compare the spatial error model because it doesn't allow to capture of the behavioral contextual effects. It's only MGR, MGWR, and MLM do this. But you can see the results between the two modeling frameworks are very similar. So it appears that we can identify the role of place or context, but we haven't really still established how important is it. Well, we can do this, as I mentioned, with MGWR, because we can take the model form here, as I've demonstrated before, in standardized form, where the variables are in standardized form, represent it in unstandardized form, and then rearrange, which gives us this, as I said before. So the vote that we see is composed of three things: a mean vote, or a baseline vote. There's a bit we add on or subtract, which is the increment due to geographical context, due to place. And then there's a bit we add on or subtract due to the population composition. So if you take these three elements for the 2020 election, here's the average county, the average vote by county. It's about 35%. The reason it's not 50% is that obviously most of the very populous counties vote Democrat. But the average vote then by county, which doesn't take into account population weighting, is about 35%. So that's our baseline. This is the vote for we're looking at the vote for the Democratic Party. We take 35% as our baseline. We then add or subtract to it these percentages, which are the percentages based upon the socioeconomic profile of each county. Excuse me. So where there are dark blues, we're adding votes because of population composition. These remember, the thing we're trying to model here is percentage of people voting for the Democratic Party. So any county that's blue means that the socio-demographic profile of those places is such that people should lean towards the Democratic Party. And this is how strongly they do in terms of vote percentages. Anywhere that's red will be subtracted from the Democratic vote because these are areas where people are more likely to lean towards the Republican Party. So we take our baseline vote and we add or subtract these values here, and then we add or subtract the bit that's due to place. So this is the influence of on the demographic vote due to geography, due to where you live. And you can see the vote variations here are quite strong, okay? This is not a minor effect. The votes can range between 35% depending on where you live. You can subtract 21% if you're living in parts of the Deep South. You can add 14% onto the vote if you're living in the West Coast or the upper Midwest or in New England. So this is a powerful impact. And that map shows us, again, this is the intrinsic preference for the Democratic or Republican Party. Anything in blue here, these counties people have an intrinsic leaning towards the Democratic Party. Anywhere that's in red here, people have an intrinsic leaning towards the Republican Party. That doesn't mean to say they vote that way. It just means if everybody had the same demographic profile, then they wouldn't vote the same way. All these people in the northern counties and the West Coast would have a predilection for voting for the Democratic Party. People down in the South would have a predilection for voting for the Republican Party. Now that map is quite amazing because you've probably seen it before. It looks like that map, the division of states during the Civil War. The blue states, which were Union states, the red are the Confederate states. These are the states in the middle, the border states, which were split. And these weren't states at all. These were territories still in the 1860s. That map looks amazingly like that one, even down to things like, if you look at Kentucky, for example, it's split. Northern Kentucky is leaning towards the Democrats, Southern Kentucky is leaning towards the Republicans. And that was a border state in the Civil War. So that map and that map are amazingly alike. So we still have this vestige from 160 years ago in terms of our voting patterns. And we're measuring it through this intrinsic contextual effect. So basically, if you take the baseline vote, you add or subtract a contextual effect, you add or subtract a socioeconomic effect, you get that, the predicted percentage vote for the Democratic Party. And that looks a lot like that. That was the actual vote. So we can model this extremely well, and we can now break it up into these three components. So it also allows us to consider two scenarios. What would happen if every county had the same mix of population? Okay, so there were no variations in socioeconomic profiles between counties. They all had exactly the same mix of population. The population were randomly distributed across the US, evenly distributed. And the second scenario is what would happen if geographical context didn't exist? If there were no such thing as geographical context, if where we lived did not affect how we voted, what would happen? Well, we can look at these two scenarios and answer them through, again, MGWR. Scenario one, what would happen if every county had the same mix of population? Well, in this case, the influence of socioeconomic factors would be zero. Every county would have the average of every covariate, right? And given the average in standardized form is zero, basically, that term drops out of our model. And we're left with the two terms on the left. And that's how we would vote if population composition were uniform across the United States. These are the votes we're predicting by each county, if the population were uniform. Scenario two, what would happen if geographical context did not influence voting? So if context weren't an issue, well, then we get rid of that term. And then this is how we would have voted without geographical context. Again, these are the percentage votes predicted from each county. So the Democrats, again, would win all the counties in blue. The Republicans would win all the counties in red. And it looks like if without context, it's hard to see how the Republicans have a path to the presidency, because the Democrats would sweep all the major states, the big population states, California, Texas, Florida, New York, and probably Illinois as well, because that's Chicago in there. So context is really important in how we vote. And that's how we did vote. And that's how we would have voted without context. Okay, so you might say, well, yeah, okay, these results might just be an artifact of the 2020 election. But no, they're not, because we've repeated this analysis for 4 elections, going back to 2008, the Obama versus McCain election, the 2012 election, Obama-Romney, and the 2016 election, Hillary Clinton versus Trump, and the 2020 election, Biden versus Trump. These are the intrinsic contextual effects displayed. They're remarkably similar. And they show some interesting features. There's a bit of a difference there. In 2012, Utah becomes red. It's intrinsically leading towards the Republican Party, and that's because Mitt Romney is a Mormon from Utah, and it captured that area. In other elections, it doesn't go Republican. But you can see the detail on here. For example, the Florida Panhandle, which is quite different from the peninsula, is part of the Deep South, and it's intrinsically Republican. In 2020, the southern tip of Florida becomes intrinsically Republican. That's probably the influence of the Hispanic vote, the Cuban and Venezuelan populations in southern Florida, which would tend to lean towards the Republican Party. And you can see a retreat of intrinsic Republicanness from the Southwest. So you can see Arizona losing its red over time, and it's now becoming a purple state, a swing state. It went Democrat in the last election. And New Mexico is losing some of its redness as well from this map. You can see that there is a retreat of the Democrat areas from the Illinois and Indiana over time. But otherwise, the patterns are remarkably stable. And also, the behavioral contextual effects are remarkably stable over time as well. Okay, so some summary and implications of this. I would argue that place or geographical context or whatever you want to call it can have a significant impact on human behavior. I think place does matter, and which is important because that means geography matters. If you don't understand the geography or the impacts of context, of geographical context, you're not going to get the models right, and you're going to have liable to all kinds of misspecification biases. Contextual effects can be intrinsic and behavioral. We do try to minimize the former by adding as many variables as we can that we think are relevant into our models, but we can't really do anything about the latter, and that's spatially varying behavior. We have to model that. And there are at least 3 modeling frameworks that exist that capture some aspect of context. So spatial error models capture intrinsic contextual effects. Multi-level models capture intrinsic and behavioral contextual effects, but the results are dependent upon an a priori definition of regions in most cases. And the behavioral contextual effects are constrained to operate over the same spatial extent. You can't have some operating at a local scale and some operating at a regional scale. MGWR and their Bayesian equivalents measure intrinsic and behavioral contextual effects, and they also generate separate spatial regimes for each contextual effect. So some things can vary very locally, and other things can vary quite regionally. All 3 model forms reassuringly produce similar descriptions of intrinsic context and also behavioral context in the case of MGWR and MLM. Recognizing the importance of geographical context has implications for the replicability of model calibration results. Clearly, we wouldn't expect a model calibrated in one location to be replicated in another location, because if place does matter. That's got major implications. So we should recognize that as being a plus for geography, not a negative. Context, wherever it is likely to be a mixture of unmeasurable attributes of places, and the effects are likely to be activity dependent. So what constitutes context in one type of behavior, voting, for example, might be quite different from what constitutes context if you were looking at, say, crime or obesity. Context or place must be included in models rather than ignored, because if you don't include them, the inferences that you draw about other determinants of behavior, the other covariates in your model, may well be misleading. And in fact, there's a good example of this in the data I've just been showing you, the 2020 election results. Here is the OLS global model results, calibrated, regression model calibrated on the same data set. These are the 14 variables, the covariates. These are the parameter estimates. They're all standardized, so you can compare these parameter estimates. These are the t-values as well. Most of these make sense. All of them make sense. They're intuitive, they're designed the right way, etc. Except for at the very bottom of this thing here, percentage uninsured, people without health insurance. There's a strongly significant negative parameter estimate here. So the dependent variable is percentage of people who vote for the Democratic Party. Why would somebody without health insurance lean towards, everything else being equal, lean towards the Republican Party, which is what this is suggesting? That doesn't seem to make, it's counterintuitive. Well, and when you look at the local model results, the local parameter estimates, you don't see any significant negative parameter estimates, apart from some strange place here just south of Evansville in Kentucky here. But there's a big swathe of positive parameter estimates, as you would expect. People without health insurance are more likely to vote Democrat, and that's what's happening here all the way from Arizona up to the Canadian border. Now, why the difference between this model, this set of results here from a model containing context, and the OLS model, which does not contain context? Well, if you look at the distribution of people without health insurance, it's higher in all the red brownie zones, the counties down here. It's low up here. That's actually quite similar to this pattern here, the local intercept. So basically what's happening is where you've got high values of high percentages of people without health insurance, those are also areas where there's an intrinsic leaning towards the Republican Party. And where you've got low values of percentage of people without health insurance, those are areas with intrinsic leaning towards the Democratic Party. So you're getting this false negative parameter estimate coming out from the OLS model. It's actually just capturing it contextual effect a little bit. So that's how you can get misspecification bias in our models if you don't include context in them. So finally, I've gone on about voting here because it's something I'm interested in, but I think there must be important application of this approach waiting to be made to better understand problems in other areas, health, for example, anywhere where the milieu in which you are situated can affect your behavior. So drug use, the opioid epidemic, the past decade, which was heavily centered in Appalachia and West Virginia particularly, there's a contextual effect there, the oxycodone kind of scandal. There's something about if you see lots of other people doing something, you are more likely to be doing it. But the same thing happens with teen pregnancy and obesity. The social milieu in which you live can affect your attitudes towards these health issues. Social issues, unemployment, crime, etc. If you're living in an area of persistently high unemployment and you don't know many people who actually have a job, then you're less likely to be looking for a job, and it leads to further unemployment. Same with crime. And the environment, things like the response to the environment, at least, take-up of electrical vehicles and heat pumps, solar panels, etc. Again, you're probably quite heavily influenced by what your neighbors and friends, etc., are doing in this area. So these are all areas where context, I think, can have a strong effect on behavior, and where we should be looking at these kind of model approaches. So I'll leave it there. I'll end, and thanks very much for attending this colloquium, and thank you again to the UCGS for allowing me to speak today. Okay.
Well, thank you, Professor Fotheringham, for a very intriguing and an extremely interesting talk. We now move to questions. We do have a few minutes, and we have here a question posed by Levi. Levi, see if you can unmute yourself instead of I reading it. You may ask yourself. Are you there? All right, so we're not quite sure. So I attempt to read this. This really strikes me as similar to the normal vote, quote unquote, normal vote literature in 1970s political science. And there, a great test of the series about normal voting of places is the collapse of the New Deal coalition over the 1940s into the 1968 election, when George Wallace broke the coalition between Northern and the Southern Democrats. I wonder whether this approach can recover that change in the intrinsic effect of geographical context.
Yeah, it's a fascinating topic, and I've thought about that myself. The change that Levi is talking about from when the so-called Dixiecrats, the Southern Democrats, switched to the Republican Party. That's a big cleavage point within voting behavior in this country, and it would be fascinating to see how well we can pick that up with this kind of modeling approach. The problem lies in that a lot of the data that we're using in these models don't stretch back as far as that period, either the voting data or more likely some of the covariates. I think we have a hard problem getting beyond earlier than 2008, I think. But if we had the data, then yeah, I think it would be fascinating to go back in time, much further than we have done, and to see these cleavage points within American voting patterns. And that's a huge one. And I think it would pick that up. I think there would be a massive, almost catastrophic change in the parameter estimates of our model.
All right, thank you. We have a next question from Danlin Yu. Behavioral similarities are, well, it's a posed question. Behavioral similarities are more like a result of peer pressure. Is that correct?
Yeah, I'm not a psychologist or a sociologist, but I'm willing to accept that. I don't know whether it's exactly peer pressure. I think just hearing the same thing repeated by different people influences how we think. And if you're living in an area where minority views are hardly ever voiced, you don't really hear them very often, so you don't get swayed by them. I think these are all possibly things that count as peer pressure. I do think they're important. I do think that we're human beings and we are influenced by people in our local environment, and we're certainly influenced by the media as well. So exactly what these are, though, and how it all works, I don't really know, because again, I'm not a trained psychologist, sociologist, etc. But I do think we can capture the overall effect of these and bundle it into something we call context. Exactly what that is that's somebody else to look into. But I think at least we can bundle it as context in our model and say, look, we've captured wherever these effects are, and at least then we know that we are on sounder ground trying to estimate the parameters of the other variables in our model.
Okay, thank you. We have another question posted by Andy Anderson. Andy, try see if you can unmute yourself and ask questions. It's quite a few lines long here. Does not seem to work.
Everybody's gone by now.
Yeah, okay, I will try to read this. A thought here by Andy. I believe that the percentage uninsured is dependent on politics rather than the other way around, well, at least recently. And there's more. Due to the Affordable Care Act and the policies of Democratic-oriented states to implement insurance at a larger scale compared to the Republican-oriented scale, they resisted. Well, basically, it's more politics then.
Okay. Yeah, so I can't speak to individual states or how it works in places, but basically we have a variable in our model that one would intuitively expect that people who don't have health insurance would tend to lean towards voting for the Democratic Party now, because it's in their best interest to do so, I would have thought. And the counterintuitive, it does seem counterintuitive that we get a strongly negative result in our global model, and that disappears when we look at the local model. So I think the local model here is much more accurate. I think it's a better reflection. In most of the counties, it's actually not significant, but there's that big swathe of counties where it is significantly negative. And I think that's a more accurate reflection of what's going on than the global model is, certainly. But as to exactly how people vote, how individuals process this information about Obamacare, etc., Affordable Care Act, and then translate that into voting, I don't actually know.
Right, thank you for that answer. We have one more, and then we probably attempt to close. This question is posed by Jiaxin Du. I'll read it. Seems this research also addressed MAUP, modifiable area unit problem. Is there more insights when you decide which spatial unit to use in the hierarchy analysis?
Yeah, it does. And again, I published with some colleagues, particularly with Miak Sachdeva, a couple of papers on this issue, on MAUP, and also its extreme equivalent, the Simpson's paradox. So at a local scale, you can get one set of results, one direction, and in a global modeling scale, you can get a completely opposite parameter estimates occurring in terms of signs. The local modeling approach, you're answering different questions at these different scales. That's the big thing about these things. But you can't say that one model is right and one's wrong, but they're answering different questions. And there's two good examples of that in our papers. One to do with house prices and what it is you're actually modeling there. And the other one, again, to do with voting. There's an example in the voting paper. So there's a couple of papers on voting in several journals, and there's a couple of papers on residential house hedonic price modeling using these local modeling approaches and picking out exactly this kind of issue about MAUP and about Simpson's paradox. And I've got a chapter coming out in the book, if Levi ever gets around to publishing it, which is all about scale and local modeling, and that summarizes these effects. I think looking at scale through the lens of local modeling is really helpful, because basically it's about processes and not about data. What you're doing in a global model is mixing lots of different processes at different scales. And at the local level, you're trying to identify to separate these processes by location. And that gives you a much clearer insight into what's going on in terms of both the Morp and Simpson's paradox. So I think these kind of modeling approaches are really helpful in understanding, I mean, giving us a different perspective and probably a better perspective on understanding the Morp and Simpson's paradox.
Well, thank you so much. I do have a couple questions. There's one more question in the queue, but based on our schedule, I think we should close this wonderful webinar. Please join me to thank Dr. Fotheringham one more time for the excellent presentation. If you have questions, please just email Dr. Fotheringham directly. Amy, you have any closing remark?
No, just thanks everyone for attending. And we hope to see you at our next webinar.
Again, thank you very much for hosting this. I really appreciate it. Yeah, great.
Well, thank you.
Thanks for joining us.
Everybody.
Okay, thank you very much. Right, bye-bye. Bye.